So this is a disk. And this is its area. And somehow I measure the area. And the area should be 24 square inches. But instead, it's 24.1 square inches. So there is an error of epsilon of 0.1. But what I'm interested in is how much should I adjust the radius? Because the area of this is 2 pi r squared. I'm sorry, pi r squared, not the circumference. I was thinking of the circumference for a moment. To give you the example, it's the same thing. The same analogy, but the area. So the area of the disk is pi r squared. So I need to adjust the radius. But by how much? So I have to go through the mechanism and find delta. Delta will give me the error of the radius. So then I know in order to have this particular area of the disk, I need to adjust the length of the radius by delta. Once I make the adjustment, then the area will be exact 24 square inches. So this is another mechanism so this is an example in real life in which we are applying what we just looked at, the epsilon delta. So you can look at the epsilon as being the error. This is my limit. This is my target. But I didn't meet my target because I have a small error. But for this small error, I will be able to determine the small error in the radius. I will make the adjustment in the radius, and then this will go back to normal. Is that a better explanation or clearer explanation?
Yeah, that's so much better. Thank you.
Perfect. So that's why this is the radius, and this is the area. And there is an error in the area of delta. I'm sorry, take it back, of epsilon, of course, of 0.4. What is the actual error in the radius that I have to make the adjustments for so that my actual area is just 2, not 2.4, not 1.6, exactly 2. So this is an application of that. Anything else? Other questions?
Can we do that as a practice problem?
Sure. So let's look at number 3. And we have, we are given the f of x, which is the square root of x. We're asked to find delta corresponding to the epsilon. So now I already disclosed that. Can anyone give us the epsilon? What is the error in the function called epsilon?
0.4.
0.4 it is. Good. So for this 0.4, we want to determine the delta right here. So we know that x equals 4. We know the function is the square root of x. I will copy it here just in case. It will not be as nice as that one. So this is 4, this is 2, this is 1.6, this is 2.4, and this is 4, and we are asked to determine delta. And we always have to choose the smallest of the two. So let me explain why we have to choose the smallest of the two. So let's say this is our x, this is the 4. Then I get here, let's say I get 4.2, and I get here, let's say I get 2.8. So I have to choose delta to be 0.2 because if I choose 2.8, then 2.8 is this distance of 1.2. From 2.8 to 4 is 1.2. And then 1.2 will be 5.2 here. And then when if I choose x to be 5, it will be outside of this interval. So that's always we have to choose the minimum delta, always. So if this is bigger, then I have to choose this distance. If this is bigger, then I have to choose this distance. Okay, perfect. So we know that the square root of 4 is 2. When the function value is 2.4, what will be x? When the function value is 2.4, what will be x? In a minute. When the function value is 1.6, what will be x? I have to solve these two equations. So if I have 2.4 equals the square of x, how much is x? What method do I apply to both sides? What is the operator that I need to apply?
Square root.
Of course, we square both sides. That's the operator that we need. The same thing with 1.6. Yes, I have the emulator there, but I thought I had my calculator handy. Yes, I have my calculator handy. 2.4 squared and 1.6 squared. 5.76, 2.56. 5.76, 2.56. That's what I got. Yes? Yes. 7656. Perfect. Okay. So I have 4 right here. I have somewhere here 2.56, and I have somewhere here 5.76. I have to find the distance between these two, and I have to find the distance between these two. 5.76 minus 4 is 1.76, and 4 minus 2.56 is 1.44. Correct? 10, yes. Which one is delta? Mandatory. Only one.
1.44.
1.4. That's it. So we like to write in mathematical symbols, we like to write delta equals the minimum value between 1.44 and 1.75. So the answer is indeed 1.44. This is the correct mathematical explanation. We have to use the minimum of these two. Very nice discussions. I love your questions. All of them, none of is silly. I would ask the same questions if I were you. So 2.5, continuity.
And you got the x equals 4 part from the statement with delta, right? The absolute value of x minus 4.
We did not use the whole explanation. We said that if the function value for something is 1.6, because this is the square root of x, so the square root of x equals 1.6, and the square root of x equals 2.4. And from here, we found that this number is 2.56, and we found that this number is 5.76. So we had to measure the distance between 4 and 5.76 and the distance between 2.56 and 4, and we had to choose the smallest.
I think my question is even simpler than that.
Oh,
the
sorry.
x equals 4 that we wrote underneath the equation, did that simply come from the graph, or was that from the statement with delta?
No, it's right here.
Okay, just checking.
Sure, it's right here. Good. Anything else? Other questions? Okay, continuity. So I'm looking at the other device at the time. I have to stop every 20 minutes, as you know. Okay, continuity. So let's take a look at this function. Let's take a look at this function. Let's take a look at this function. And one more. Or so these are all functions, and we want to identify continuity, meaning continuous functions. A function is continuous if I can draw it without lifting my pencil marker off the paper. If I have to lift, a function is not continuous. Lift, function is not continuous. lift, function is not continuous, lift, function is not continuous. So this is the only function that is continuous. Not continuous, not continuous, not continuous, not continuous. These two have a very special name. They're called removable. Discontinuity. This one is called jump, discontinuity. And this one is called infinite discontinuity. Now, a theorem, and it's common sense. You're going to tell me how to fill this in. A function is continuous on an interval if it is continuous at each and every on that interval. Each and every what? On that interval.
Point.
Yes, on that interval. But we have to talk about continuity at a point. So this is clear. So if a function between these 2 points is continuous, it must be continuous at each and every point on that interval. But what does continuity at a point mean? Continuity at a point. Now, do you remember when we talked about limits? What did we say about this? Does this function have a limit at 3? The limit as x approaches 3 from either side of f of x. Does it exist or not?
It does exist.
Yes, exists. Because as we know, the concept of the limit has nothing to do with the function value at that point. But if I ask you f of 3, what will you say? Which is a totally different concept. What will you say?
Does not exist.
Thank you very much. Awesome. But continuity at a point is based on this. But this, which means the limit from the left equals of the function equals the limit from the right of the function, but it must equal what? If the function is continuous at that point, it must equal to what?
F of x.
Yes, of course. Yes, of course. This is a definition of continuity at the point. Limit from the left equals the limit from the right equals the function value at that point. Great. So we open the floor for questions. Good. Is this function continuous at -4?
No. No.
No. What type of discontinuity is that?
Removable.
Excellent. What about at -2?
No.
What type of discontinuity?
Jump.
Perfect. What about the discontinuity at -1?
Infinite?
Yes, awesome. Good. Is this function continuous at 3?
No.
No. It's a removable discontinuity. What is the function value right here, whatever this number is? I don't know. I can't tell. 2. I don't know. Okay. So again, here in this section, of course, the piecewise defined functions are the queen of the section. in which we are given a piecewise defined function and we are asked, what type of discontinuities do you see? So would you like to look at another piecewise defined function?
There was a problem a little bit down that showed that the function had a removable for 25 and 26.
Okay,
How would you show that it would have a removable
very good. So let's start with that. That's even better because we looked at that piecewise defined functions enough. Good, awesome. So let's look at 25. And we have a show that f has a removable discontinuity x equals 3 and redefine so that it's continuous. Awesome. Very good pick. X minus 3 over x squared minus 9. Perfect. Perfect pick. Thank you. Okay, so when we look at this function, now we're not graphing, we're not asked to graph this function, but we have to think in terms of the domain first. We have no choice here. So in order to find the domain, I will definitely have to do what?
Set x equal to 0.
When we find the domain for a rational function, I already gave you the hint, right?
The denominator to 0.
Good. So let's factor it in order to discuss that situation.
X plus 3, x minus 3.
Notice that you're not allowed to simplify. Please remember, the domain of this function or any function has to be stated on the original, not on the simplified form. So can anyone give us a domain before we try to simplify? We're not allowed to simplify before we state the domain.
It would be negative infinity to negative 3, and 3 to positive infinity.
Careful.
Or negative 3 to positive 3.
Excellent.
And then positive 3 to infinity.
Perfect. Now I'm allowed to do this, but I have to write 1. If you don't write 1, I've seen it as 0 over x plus 3. That would be a terrible mistake. So what is the simplified form of this function after we state the domain? Note, domain to be stated or determined on, I didn't mean that, the original function. It's okay if it's factored or factored, but not simplified. So what is the simplified form then?
1 over x plus 3.
That's it. Awesome. Brilliant. Thank you very much. So the function, this function is simplified into 1 over x plus 3. And we realize that the function does not exist at negative 3 and positive 3. But the problem, let's go back for a moment. The problem is only asking us what happens at x plus 3. Okay, I didn't mean that. Okay, so we're not going to discuss this. This is clear. They want us to discuss x plus 3. Perfect. So we know that at x equals 3, the function will have a hole. How do I know? It's because the factor went away. If the factor of x minus 3 from the top and the factor from x minus 3 from the denominator went away, the function has a removable discontinuity at 3. Guaranteed. So now, in order to, they're asking us, so we showed that x equals 3 is a hole. Hole means removable discontinuity. That's all it means. But now in part B, so this was part A. In part B, they say, make it continuous at 3. Rearrange, write the function again. Okay, fine. Here's how I would write the function. As 1 over x plus 3 for x not equal negative 3. And for x equals 3, all I have to do is plug it in. Why? Because the limit from the left and the limit from the right at 3 have to be the same. So simply plug it in. What do you get?
1/6.
1/6. So now the function, not 3 and also not 3. So now the function is still discontinuous at negative 3, but they did not ask us to do anything with negative 3, and we cannot do anything to that. But at x equals 3, so that there is a vertical asymptote at negative 3, nobody can change that. So we know that here, x equals negative 3 is a vertical asymptote. That is carved in stone.